Thank you for coming, especially after that delicious popcorn. So yes, I am Ryan H. Lewis. I like to include the H because it's kind of difficult to Google my name now, thanks to Macklemore and his friend. So you were at the talk, No Side JavaScript and the Serverless Revolution. A little about me before we start. I do have an update to my bio. I'm no longer at Expedia. A few weeks ago, I started at Koali, a local company you may be aware of, doing some similar JavaScript stuff there. Like I said, we never prepare these things for intros because usually there aren't intros, so now it's a little awkward. You already know everything that's going to happen. So yeah, instructor at Pluralsight. I do courses on AWS and other JavaScript things. And Meatcube is my record label where I release underground Japanese stuff, hardcore punk music, and I've been doing that for a while. I'm the executive thing doer there. So before we start, it's kind of cool that we're actually in a movie theater because I have sort of a trailer, sort of a metaphor, sort of a story to kind of start this talk off with. So I don't have the deepest voice, so imagine this in that movie trailer deep voice guy voice. But we're going to talk about kind of what I view no-side JavaScript, a metaphor again. The year is 2017, planet Earth. Fulfilling Atwood's law, JavaScript engineers rule the world, solving every problem with closures. Two factions fight for control over the sacred text, ECMA 262. Each with their own interpretation of the Holy Script, argue over amendments to each annual edition. The client-side JavaScripters, devotees to browser culture, even they are divided into further subcultures, Angularians, jQueryals, and Reactites, to name a few. And the server-side JavaScripters, event loop process worshipers who share code through an interconnected cyber repository called the Neo Particle Modulator. Both sides reside in the hugely popular cloud stacks, oversized high-rises central to the web. For years, the two groups struggled for dominance in the cloud stacks, but now a new paradigm has unseated both for the true CEO position, serverless, an interconnected operations team destroying overlord that makes virtual server management a thing of the past. None of the JavaScripters could withstand the overwhelming presence of serverless. The lack of servers brought down the server-side JavaScripters as they ran into the dreaded serverless limits. The client-side JavaScripters lasted longer, but eventually succumbed to the complexity of the build scripts they used to navigate the serverless labyrinth. Therefore, a new type of JavaScripter has emerged that runs circles around serverless. They understand the limits of serverless and have developed patterns to navigate even the most complex serverless requirements. These are the no-side JavaScripters who look down at the cloud stacks as they ascend to a distributed cloud nirvana. So that's the story. That's the trailer. Thank you. So for this talk, I'm going to talk about the JavaScript, how JavaScript kind of works with serverless, but also serverless in general. It's still sort of newish. Some people may not be that familiar with it. So I like to start from the beginning because I feel like serverless is sort of a revolution, but also a little bit of an evolution as well. So I like to kind of go back to the beginning of web development. And it started out where there was on-prem. There was on-premises servers. You own the hardware. You had to buy a new server. You had to make sure it was connected. You had to make sure it was cooled, upgrading any software that was required. And then you were managing those servers from an application standpoint. You were also getting your applications on there. Pretty much it was all in your court. And one of the most important things is you're responsible for all of the costs. So this is kind of the way that the web developed for many years. Probably about 5-10 years ago is when a new thing started to emerge that kind of evolved past this on-premises service. And I do want to caveat that it's not that these things are being replaced. We obviously companies still use on-prem. Cloud migration is still a thing that happens today. But the cloud came along and kind of revolutionized software infrastructure and application infrastructure. And what it mainly provided was this virtualized hardware. So no longer were you having to own your hardware, no longer were you having to connect it. Your application wasn't even necessarily running on a single box. It could be running on, it could be one of many things running on a single box. But it was all virtualized for you. But you still did have to do the application management. So you did have to make sure that your Java application was running and it didn't run out of memory or threads, and that if it was a web application, it continued to listen on ports and things like that. But there was kind of another evolution with the cloud, and that was being able to pay as you go. So you were only having to pay for the instances that you were using, and if you were to say stop using an instance for a while or a server for a while, you didn't have to pay for it. Your cloud provider, whoever that was, would be paying for it sitting there idle, which is nice. And so a few years ago, this was probably, I believe, the first kind of real serverless thing launched in 2015. I know I'm getting this wrong, but it was AWS Lambda, and it kind of kicked off this entire serverless idea. Other cloud providers followed suit. Pretty much every cloud provider now has their own application of serverless, their own service. And so it brought along a few things that kind of, if you can see, there's this progression. This is the next step in the progression past on-prem in the cloud, where you no longer even have to configure your infrastructure. So with the cloud, you still have to do that. You still have to tell which servers are going to be running which code and make sure they're connected via VPCs and all this stuff that you just don't really want to have to deal with. So serverless brought along the new model where you don't have to do that. There are a couple configuration things that you have to do, but they're super minimal and you don't have to do them. It'll take care of it for you. It really lets you just run your code. You give it code to run and it runs it for you. You're not having to make sure these processes stay up. You're not having to care about which server it's running on and whether that server needs to do an update. It's really nice. And in the kind of financial space, it also brought along another innovation, which is you only pay for when your code runs. So no longer is it you pay for when your server is alive, that you're using that server. It's even beyond that, where you're only paying for when the code is run, which is pretty cool. So let's look at some graphics to understand kind of how serverless functions work. And you've got your cloud provider, and serverless functions are all event-based. So you have an event come into that cloud provider. That event could be internal to the cloud provider, but somehow an event is being fired, and there's some way that your cloud provider is resolving that your serverless function should handle this event. So when that happens, the cloud provider, if this is like a cold start, hasn't looked at your code for a week, it will take your function and it will boot it up into memory on some server somewhere. That's the secret of all this. There are servers still. And your function will respond to that event. Once the event is gone, the cloud provider will leave your function on whatever server instance that it was running on. Which is nice because when an event comes in again, your function can run right away. You don't have that boot up time. And then the event goes away, it's being processed by your function, and your function is left behind. So with serverless, there's something that you'll come to understand is there's cold starts and there's warm starts. It's not really a warm start, but when your function is being regularly fired by events, it keeps your function warm. And so if your function is cold, it hasn't been touched for a while, there is some boot up time involved. And a lot of times I can see that as kind of one of the things that when people are learning about serverless, they're afraid of something like that. Oh, that's really bad. That boot up time is going to kill me. With node serverless functions, it's milliseconds. And you have this process to keep your function warm, so it keeps your function running on a server somewhere, but you're not having to pay for the entire time that it's running on that server. So eventually the cloud provider, it sees that your function hasn't been called for a while, and so it brings down your code and it puts it somewhere. So let's look at some bullet points about what serverless is. First of all, it's simple. It auto scales for you. You don't restart instances. It's really easy to get started from a developer who knows nothing about DevOps. You can get started in serverless probably faster than anything else that I've found. It's also empowering. And this is kind of one of the things at Expedia in my previous life, we were doing serverless for about 1.5 years. And one thing I found is that when we started working with serverless functions, it kind of changed the way that developers felt about their code. And I felt that it really empowered them to feel more responsible for the code that they were pushing. There wasn't a barrier between them of a DevOps team. And I would say that even more, it simplified the way that their code was getting to production in a way that they felt like if their code went down, they felt more responsible, so they cared more about it. And I thought that was really cool, and it's kind of like a side effect that I didn't really know about. So the last bullet point for this slide is that serverless is event-driven. So you saw the event comes in, your serverless function runs. That's the entire model of these serverless functions, is that events are going around, you're responding to them. Events could be HTTP endpoints, they could be something from a message queue, they could be changes to some file system somewhere. There's all sorts of different types of events. Every cloud provider offers different events, so I can't really say, there's no like canonical list of events that you can say for serverless. But this is kind of where the transition takes place because serverless is so event-driven. Hopefully this conference, event-driven, evokes a certain language in your head in that JavaScript and Node.js is also event-driven, right? And so when we were doing serverless for the past year, we were doing it exclusively using JavaScript, and we found that there was a very interesting synergy between serverless and JavaScript. And it was really, it's not necessarily that JavaScript is the only thing that can run on serverless, but there were things that just felt right, and there were things that just made sense. And as a continuation of that, the JavaScript that you write with serverless is a little bit unique compared to server-side or client-side JavaScript. And so I thought that JavaScript and serverless kind of needed its own special name, its own clique or club. And so I thought no-side JavaScript worked well with the serverless, the lack of servers name. But it really just sounds cool. There's no-side doesn't make any sense. So, but it does sound cool, right? So I kind of, I boiled down a lot of the rules that I learned over the year working with no-side JavaScript and JavaScript on serverless. And I thought it would be good to kind of bake these into principles, and they're not really rules, they're just kind of pointers maybe for when you're doing JavaScript on serverless and gotchas to watch out for. So the first principle is to forget what you know. So one thing I didn't specifically say yet is that when you're running JavaScript on serverless, it's using Node. So Node developers, existing Node developers may be a little bit more familiar coming into no-side JavaScript and running JavaScript on serverless. But for them especially, you want to forget what you know because there's no HTTP server. So your functions on serverless are essentially pure type functions. They're not pure in the functional sense, but pure in the sense that there's no process that you're dealing with. You're really just writing the code, and you expect some output or something to happen. There's also no state. So this is another thing that gets a little scary when you saw how the cloud provider stood up and tore down your function. And that happens so many times. There's no state involved with that function. Every time that function executes, that it responds to an event, it's brand new. and there's no state involved. So you do need to be aware of that. And then there's no long-running processes. So you don't need PM2, you don't need forever, you don't need to worry about memory leaks or any of the other things involved when you're running node processes. So all of these things are things that when you're working in Node, you think long and hard about. And when you move to no-side JavaScript, you don't have to think about those things anymore. There's other things to think long and hard about. All right, so principle 2, one function, one purpose. I kind of felt like this principle was needed as a response to how I saw some people writing no-side JavaScript and writing serverless functions. When you write serverless functions, you want to try and modularize your serverless functions in a way such that each function really has one purpose for being. I like to kind of follow a modified, more kind of loosey-goosey version of the single responsibility principle, and try to maybe it's a little bit of separation of concerns as well. But I try to keep different concerns and different responsibilities in their own functions. An example of this is if you have like an API that you're building out, each one of those API verbs or operations could be its own function, and that would kind of make sense from a modularizing standpoint. But you definitely don't want to build a monolith, and I say this because I've seen people build monoliths on serverless functions, and it's terrifying. And so it's definitely not something that you want to do. A good way to see when you need to pare things down and break out your functions is you can track the invocation time of your serverless functions, and you can see that serverless function itself responding to a single event, how long it was running for, and it calculates it in milliseconds. And ironically, this is the same way that you're charged from the cloud provider. But tracking that invocation time, when you've got a serverless function that I would almost say if it's running for longer than a second and it's not waiting for something else, you definitely need to break that up. But you can use that as a good kind of measure to understand when you need to break things up. Principle 3 is to think distributed. So when working in no-side JavaScript, services are your friend. I mentioned that you don't have state, so you're going to have to use something else for your state. You also don't have HTTP server, so you're going to need to use something else for your HTTP listener. Also, feel free to put the fun back in functions. Sorry, that's a bad pun. The more functions is not necessarily bad, and I know that right now you may be like, yeah, this sounds cool, but like, I tried it and I got to 5 functions and I never want to do this again. Well, I've got some solutions in the end of the talk, but feel free to make more functions. I mean, I would not be afraid if a largish application had 100 lambdas, 100 serverless functions running. I think that would be pretty reasonable. But definitely keep it practical. There's kind of a certain way of reading a lot of these things where you kind of go crazy and you seriously do single responsibility principle, and every function is literally its own function. And then you've got thousands of serverless functions and you say, Ryan, you told me to do this. And so this is my kind of like back out. I said keep it practical, so you shouldn't do this. So be reasonable about the way that you are distributing things up and the services that you're using. And a lot of times you may not need that service that you really want to use, even though being distributed is better. So this is a very interesting gotcha. And it makes sense, but I was surprised when I encountered it. With serverless functions, you're running on a read-only file system. So if you're used to client side, then this is probably, you could care less. But if you're used to working in Node, then you understand that usually the file system is your friend and you can do things to it. Well, in a serverless function, your file system is read-only. So anytime you try to write to it, you get an exception. It's pretty nuts. So you have to kind of utilize different things to mitigate that. You can use cache, you can use databases, probably a combination of the two is good. And then you can also use static storage, think like S3 and AWS, and definitely utilize CDNs for delivering files. I wouldn't send files back from a Lambda. I think that's probably not a great way of using that serverless function. Principle 5, know your limits. So just like when you're running in a browser and you have to think about what the JavaScript API that the browser supports, or if you're running in Node and you have to think about the memory that your instance has, in serverless there are also limits, but they're different limits than you're used to. Like for instance, there is an upload and function size limit with serverless functions. So when you upload, there's a limit to the amount that zip package, and by upload I kind of mean deploy. It's probably a better word for it. But there's a limit to the size that package can be. In AWS it's 50 megabytes, which you may think sounds really big, but when you look at the size of your node modules folder, it doesn't seem so big anymore. So there's a 50 megabyte upload limit, and then the function size limit. Once that package has been expanded, it has to be less than 250 megabytes. So it's definitely something that working in the past with serverless, I've had to be a little smart about some of the libraries that I've included. And it's also eye-opening to see which libraries are really huge and which aren't. Like, if anybody uses Moment, that is a huge library. I don't know why processing needs to be that big, but there's also a limit to concurrent invocations. So this is the number of running serverless functions that are running at once. This is a soft limit in AWS. So in AWS, 1,000 is the initial default limit, and then you can get more if you need to. But this is something that when you're running a lot of serverless functions in a company, and if your company is using one AWS account, then this is a limit that you really have to be aware of from kind of an overarching view. And then there's also timeouts for serverless functions. So again, with the AWS example, your serverless function can't run longer than 5 minutes in a single invocation. And then additionally, that's like the top timeout. That's something that you can configure. So I think the default is like 3 seconds. So it's definitely something you need to be aware of, and you want to set it at like a good place for your serverless function itself. But there are also resources. So there's also memory and CPU involved. It's nice because it kind of wraps memory and CPU together. So you only set the memory, and as you set the memory higher, you get more CPU cores. I don't know if they did that on purpose or that's just kind of a result of which kind of instance server type that they're putting it on, but it's nice because there's just not much to configure. And then the last principle is static version. So when you're running a serverless function, you're running on a static version of Node. In AWS, they have 2 versions that you can choose from. Version 4 or version 6. You'll notice those are both LTS versions of Node, so they do keep on the LTS branch. But there's a nice thing, I feel like it's a nice thing, in that it gives you a stable build target. So a lot of times when you're writing, I'm kind of a child of the browser wars, I guess you could say. So I remember the days where browser compatibility was one of like the #1 things on your resume. You don't have to worry about that anymore. And I find that really refreshing working in JavaScript and knowing exactly what things are supported. So it gives you that stable build target. But it's also not bleeding edge. So if you keep up with Node versions, version 8 is the newest version. I believe it either just went LTS or it's going LTS very, very soon. But you can't use that yet in AWS Lambda, for instance, because that is still only offering version 4 or version 6. So, you can't use async await with version 8, on Lambda, which it's not that great, but it's a trade-off. But an even more kind of maybe worrying thing is that they're slow to update patches. In general, serverless cloud providers that offer serverless services are slow to update their versions of Node. And this normally wouldn't be that important, except if you, again, keep up with Node news. A few months ago, there was a big bug that they found that had a security flaw, and they had to push new bug fix versions for every version of Node they supported. It was a huge thing. They still have it on the front page, nodejs.org. They've got big security announcement. And if you're running your own services, you're cool, because you just go, you update the Node version on the bug fix version, and you're good to go. But if you're running a serverless function, which is running on a cloud provider's serverless service, they control the Node version, which means that it's kind of up to their discretion whether they're going to update and fix a security flaw. Google Cloud Platform pushed an update a couple weeks after the security releases were made. Unfortunately, I haven't checked in about a month, but unfortunately, AWS is still running on the flawed security version, which is kind of something, when you think about investing in serverless, it's something you have to be aware of. Granted, that security hole was just for HTTP. You're not using HTTP very much in terms of a server on serverless, so you are probably safe with your code that is running there. But it's just something to be aware of. All right, so with all of those kind of principles and details and stuff, how do you serverless? Well, there's a couple of concerns that you want to think about before you use serverless. Like you could, I'm using it like a verb now, sorry. You could totally just go into it blind and just be like, yeah, I'm going to do this, and then eventually you're going to hit all of these concerns, I guarantee you. First of all, how do you do local development? Like if it's running on a serverless function somewhere in some cloud provider, how do you avoid having to push your code every single time you mistype a variable name? You also need to worry about how do you deploy. Deploying a single serverless function isn't that hard. You just upload it through your CLI tool or through the browser. But when you've got 20 or 100, all of a sudden that'll take you all weekend, and it doesn't seem feasible anymore. You also will be concerned about resources that are being created. So with the serverless, when I talked about keeping things distributed, you're going to be using a lot of different services in your cloud provider outside of the serverless function, outside of the code that you're actually writing. So how do you create those, and how do you kind of tie them together with your code that you're writing in a way that kind of makes sense and allows you to be very flexible in creating and tearing down those resources? And the solution that I'm offering to you is Serverless, the framework. So this is a genius marketing move for the team that came up with this framework, but this is essentially a framework that allows you to work with serverless in a very easy and very happy way. The serverless framework gives you configured deployments. So it allows you to configure everything that you want for your serverless functions and the environments that they'll live in and the events they'll respond to and any resources that are being created. You can put all of those in a configuration file, and it's really, really simple. Then they have a CLI. I think every framework these days has to have a cool CLI, right? So serverless is no stranger to that. They have a really nice CLI. It's constantly updated to do more and more, and it's really great. And serverless also has a robust plugin architecture. This is important because serverless doesn't do everything yet. It's open source software. It is being created by a company, but the development team that works at the company is fairly small. So you can imagine that if you've got some feature or something that you need it to do, it may take some time to get into the framework itself, which is why having this plugin architecture is really nice. it feels similar to me in the way that if you've ever written a plugin or a loader for Webpack, it's very similar in that you kind of are able to plug into the serverless lifecycle and have your code and do different things. So all of these things make serverless really nice compared to not having serverless. So another diagram just to kind of see what serverless does for you. So the pieces that you work on are the serverless configuration file, and they offer YAML or JSON, and then you've got your code. So this is just basically a JavaScript code base. You push that into serverless, and serverless does all of these things at once for you. It will take, and these are all AWS examples, but it'll take your code, it'll put it on a Lambda, it'll create an API gateway if you have some HTTP endpoint that you're listening to. It'll create an S3 bucket that maybe you've configured in the CloudFront or the CloudFormation template. It creates DynamoDB tables. It can create databases. It does kind of everything that you need to do, and it does it all with like a super simple command. I'm going to show you what it looks like, but the key thing about this is if you're getting into serverless development, I almost feel like you should do all this stuff manually first, because it's not fun to do. And when you find serverless and you start doing it with serverless, all of a sudden it's just, it makes you love it that much more. Serverless is cross-provider, so it works with AWS, Azure, Google Cloud Platform, IBM OpenWhisk, SpotInst is one they launched last week, and Kubeless they launched a few weeks ago. So it kind of works with everything, and if you wanted it to work with something different, you could just write your own plugin, which is super cool. And getting started, this is literally, you can do this in your command line right now, and you will have a hello world pushed out. So npm i-g serverless to install the serverless CLI globally. Serverless create -- template. They have these templates, which are basically hello worlds. It'll give you everything that you need. This is the one for Node.js, and they've got them for all the different languages. You don't have to do no-side JavaScript with serverless. You could do no-side Java, if you want to call it that. It doesn't have a good ring to it. And then you run serverless deploy. If you've got your, in this case, if you've got your AWS CLI all set up, this will literally put out a serverless Lambda, and it will output the URL link that you can click on. You can go look at it. I find this like pretty crazy simple to get started, and you can actually like have something running in production with 3 commands. That's pretty crazy. Okay, so if you want to learn more about serverless, the framework, check out serverless.com. If you want to learn more about no-side JavaScript or just kind of re-look at these things, I'm working on the nosidejs.com site. Yes, it is being run by Serverless Technologies, of course. Yep, and that's it. I have free stickers. I made stickers of the nosidejs logo thing, so please, I've got a bunch, and I don't know who else to give them to. I also have a YouTube channel. I do videos on new versions of serverless, web technologies. Ryan H. Lewis is how you would find me on there. And I'm at Ryan Murakami on Twitter and GitHub. Thank you. Two minutes for questions. Does anybody have questions? Yes. Is there any benefit to serving up static content? There could be. I would say if it won't fit in a CDN, then there may be. But I would think about, is a CDN a better fit for it? Like, is it for real static? Then it probably deserves to be in a CDN. But if there's some sort of logic or resolution that's required to get that file, or if that file needs to be dynamically generated, then serverless is a good kind of other solution. And it's a lot better than having like a server that you stood up and is sitting there listening. Anybody else? Oh, yes. what are some good use cases for serverless or typical use cases? So I will say we got to the point in Expedia where the default was serverless. You basically had to have a reason not to work on serverless. So I would say that serverless works for almost anything. I think people use it a lot of times for being so in AWS you've got cloud development. A lot of times you've got either data or you've got files being processed. Serverless functions can listen for those events to fire, and they can do some data processing once things happen. So a lot of times if you think in the database world there's like ETL processes, you can make your ETL process with serverless functions instead of relying on a tool for that. You can also use serverless for just a website, and it can do, and that's actually what we've done quite a bit. And the idea for that is that your initial file that it serves has some logic that needs to happen. It might not be like statically rendered, but you may need to like create a session or set some cookies or do something. You can use a serverless function for that, and then all your static files like your JavaScript and CSS can come from a CDN. So it can do that. Yeah, I think those are the two major, but I've really seen it do kind of everything. It's also good for like kind of like an API layer for the back end. Yep. Oh, okay. Thank you. You can come talk to me later.